In this question, we have to go back to the equation. Check that the equation is balanced and then work out the ratio. This means that we are working out the number of moles of each compound in the equation. So we find this out by looking at the coefficient in front of each compound. So that means the ratio is 2 is to 1 is to 1 is to 4. So we have 2 moles of sodium hydroxide that reacts with 1 mole of oxalic acid solution to form Na2CO, C2O4 and 4 parts of water. In the previous question, we calculated that the number of moles of oxalic acid solution was 5 times 10 to the minus 4. And if the ratio is 1 is to 2, we must then multiply that number of moles by 2 to find the number of moles of sodium hydroxide. Our next step will be to calculate the concentration of concentrated sodium hydroxide. So we're using the formula C is equal to N over V. We substitute the number of moles, and then we were given the volume 19.93 cubic centimeters, but we work with cubic decimeters, so we divide by 1,000. This gives us the concentration of sodium hydroxide in a dilute solution. We then want to use that answer to calculate what is the concentration of sodium hydroxide in a concentrated solution. So we substitute the dilute concentration here, multiplied by 100, and the concentrated solution is what we're looking for, times 10 for the dilute, for the concentrated. This gives us the concentration of 0.5 cubic moles per cubic decimeter. We're now going to substitute to find the hydronium ions. So we use this formula H3O plus times OH minus equals 10 to the minus 14. So we already know, since sodium hydroxide it's a hydroxyl ion, we substitute the value 0.5 for the hydroxide and we solve for the hydronium ions. This gives us a concentration of 2 times 10 to the minus 14. We can now solve for the pH. pH is equal to minus the log of the hydronium ion, and that is 2 times 10 to the minus 14. And then your pH is 13.7. For this type of question, in order to help students to get the maximum number of marks, always start with, is the equation balanced? Once you've checked that, calculate the mole ratio. Use your mole ratio to then find the concentration. Look for the concentration of the solution that you have the most information about, so the dilute or the concentrated. Once you have this information, use that information to solve for the other concentration that you're looking for. So if you have the dilute, solve for the concentrated. If you have the concentrated, then solve for the dilute. So you're again solving for concentration. You'll use that answer to substitute into your formula for hydronium and hydroxide ions equal 10 to the minus 14. This will give you the hydronium ions or the hydroxide ions depending on whether the substance is an acid or a base. In this case, the substance is a base. So when we substitute and find the pH by substituting the hydronium ions, we find the pH to be 13.7, and we know that bases are all higher than 7. So the pH for sodium hydroxide is 13.7.